Going. Are we going? Anyone want to say hi to YouTube? Hello, YouTube. Okay, real numbers and the real line. So this should all be reviewed. Don't worry, all of these slides are going up online, so you don't have to take. You can write if you choose to. You may want to just pay attention. I'm interesting. Okay. So you guys seeing the real numbers, yeah? This works better if at least one of you says yes to me. You guys are seeing the real number line, yeah? Yeah, okay. So what is it? What are the real numbers? Can anyone give me a definition? I'll just wait. Even wrong answers are going to get us. Okay. Is 1 a real number? Okay. What else are real numbers? 2? Anything else? 1.2. Okay. Yeah, these are all real numbers, but can you give me a property that sort of ties this all together? Have you ever thought about this, what a real number is? This is basically why I'm asking you this question. You don't actually have to know the answer. I just want to prove to you that like math is necessary and hard, right? Because if you can't give me a definition of this real number line, right, that's like the first question out of the gate. What is a number? Have you ever really thought about this? Okay, so we have integers, right? 1, 2, the counting numbers, even the negative ones. Where do we have to go after that? So what do you mean by a decimal number then? Do they? Is 1.3 a real number? Yeah, it is. Answer with confidence. Those numbers, though, that you're saying, right? If you give me any decimal number which has a finite, like it's not an infinitely long number, what that basically is a fancy fraction, right? So 1.2 is just 12 over 10, right? So we have integers, we have negative numbers, then we can take integers and make fractions. And what does that give us? Yes, miss? Pardon me? The rational numbers, right? So is the real numbers just the integers plus the rationals? Yeah. Complex numbers is not a rational, nor is it a real number. So you went one step too far. Okay, so we have fractions. We have integers. What else do we got that are real numbers? Yeah. Irrational is getting closer, but so what's an irrational number? Sure, but can you give me a property that ties them all together? Yeah, so you have rationals and you have irrationals. So what's a rational is a number that can be written as a fraction. So an irrational number is what? Well, it's in the name. Irrational means not rational. Okay, so we have numbers that can be written as fractions and numbers that cannot be written as fractions, which is kind of cheating, right? Because the numbers that can't be written as fractions like are necessarily like the universe of real numbers. Anyway, so the real numbers are the collection of any number that you can write as a decimal, including decimals that require an infinite number of digits to be written, like pi. Pi has an infinite number of digits with no pattern associated with it. It's not representable by any fraction. The square root of 2 has an infinite amount of digits required to express it. It also has no fraction that's associated with it. So, precisely, the real numbers are the set of all decimal numbers. But the precise mathematical definition of real numbers are all the points which rational sequences can limit to. And you don't need to understand that. But for those who are here a second time, that statement should make sense now, right? We taught you about sequences. We taught you how those sequences can limit. So I can make a sequence of rational numbers limit to pi, right? And if you take the collection of all of those limit points, you end up getting the real number. So you just need to understand the first one. I just thought that was a fun fact for your first day of summer learning. We also have to be able to sweep out regions on the real line. We need collections of numbers. So we can have this thing called there are several ways that we can express subsets of the real line. So we have this thing called a closed ray, which is this set. So it's all numbers, A, inclusive, a square brackets means inclusive, to infinity, which is always excluded. You can never actually get to infinity. That's the purpose of a limit. So a closed ray are all x's such that x is larger than or equal to A. And does anyone know what this symbol means? Oh, no? Yes. Subset, yeah. So it means that, so these curly braces indicate that you have a collection of numbers. That's called the set. It's equivalent to this set. And both of these sets are a sub-collection of real numbers. And so all it means is that all the numbers that you will find in here are also real numbers. So I'm saying, let's take a subset of the real numbers. So I'll use this symbol often. We can have an open ray. That's all the numbers from minus infinity to b, exclusive on both endpoints. And we usually denote the fact that there's b is not included by using an open circle like this. And then we can just have the whole real number line, which takes you from minus infinity to infinity. Right? So these are just ways of expressing regions of the real number line. These are the ones that are used more typically: open intervals, closed intervals, and half open intervals, which are sometimes called clopen. So if you go from curved brace A to curved brace B, that is all the numbers between A and B, excluding the endpoints A and B. So that's why we have these open circles. The closed interval uses these square brackets. It's practically the same as the open interval, except this time that we include the endpoints. And half open or clopen means that you simply exclude one of the endpoints but not both. Right? So we'll probably never see these pictures again, but for sure we'll be using these notations quite a bit. Any questions? If there's any questions, just raise your hand or shout at me. It's fine. Some extra fun facts about the real line. The real line has no holes. That is to say, if you choose any two numbers on the real line, there's going to be an infinite amount of numbers in between those two numbers. So do you know that there are different types of infinity? So you start counting the real numbers, right? You can count the natural numbers, 0, 1, 2, 3, 4, and those go to infinity. That's called countable infinite, right? Because you can say if you have an infinite amount of objects and you can arrange them in order, you can count them. That's called countable infinite. For the real line, if I give you the first real number as 0, what's the next biggest real number? Well, whatever number you pick, I can always go smaller. And I can repeat that. Right? So the real line is called infinitely dense. You don't need to know that. I'm just telling you that this math can get actually arbitrarily sophisticated if you really want to. You can actually count fractions, believe it or not. So if you just imagine a big grid, sorry, YouTube. So if you just imagine a grid like this, right, where this is the point 3, 3, you can regard this as the fraction 3 over 3. Right, so you can actually count the fractions by doing this through the grid. I can order the fractions. That's pretty cool. But you can't do the same thing with the real line. So the real line contains all numbers that are integers and rationals, and also the irrational numbers, which includes things like square root of 2, e, pi, and negative pi. Right, so we're going to be mostly working with the real line always. Here are other ways that you can generate sets of things. You can just give a pattern. So A is the set 1, 2, 3. So that would just be the set of the naturals, excluding 0. You can have a pattern like this: 1, 1/2, 1/3, 1/4. The next one would be 1/5. Or I can generate sets using something called set builder notation. So this is the collection of numbers x. Those two dots you should read as such that. So this is x such that x squared is greater than 0, which would be, well, what is that set? What are all the numbers whose square are greater than 0 among the real numbers? That's included, but that's not all of them. What about negative 1 squared? Doesn't that go to 1? What about 0? That's not bigger than 0. Exactly. So is 0 in the set C? No. So real numbers is close, but you have to remove one number. Which one? I heard the whisperings of the solutions. You should say them out loud and I can give you credit. 0. Right, so the C here would be the collection of real numbers excluding 0. Be careful. Those types of nuances is how we're going to trick you. Right, so you have to become very detail-oriented in this space. So a real number is any number on the real line. It may be an integer, a positive or negative number, a fraction, or a decimal. Real numbers that are rational are expressible by fractions. So 2, 0, minus 7, 2/3, minus 4/5. So here it's already interesting to know that a fraction can generate something that's infinitely long. Right, so infinitely long decimal representations don't necessarily give you irrational numbers. Oh, that's definitely wrong. It should probably be a half. What was I trying to write there? Likely. Yeah? I heard it. This should probably be a third. No. Yeah, a third. Because anything over 9 gives you that repeating. So that should be a third. So real numbers that are not rational, square root of 2 pi e. If this was the other non-life sciences calculus, I may ask you to prove that there is no fraction such that root 2 is that fraction. You can give it a try if you want. It's in your capacity to be able to give me an argument as to why the square root of 2 doesn't correspond to a fraction. You can think about that one on the bus. You should always have something that you can think about when you're like waiting in line or on the bus or in the shower. So this is why you should always be reviewing math, right? Just so you can say, I'm bored. What about that problem that I was supposed to solve? It's a life hack. Are there any non-real numbers? Miss, why don't you tell me what you told me before? Complex numbers. So, you don't need to know what a complex number is, but I just want to let you know that we have to go further than real numbers eventually. So there's these things called complex numbers, and the complex numbers just introduce a single weird thing, this I, which is the square root of -1. We told you that you can't take the square root of negative numbers, correct? That was kind of a lie. Right? You can, you just need this extra number, which is defined to be the square root of -1. But we are not going to use that this year. You need to know how to work with the absolute value function. It's a little bit tricky, but all you have to do is remember this. I recommend whenever you see an absolute value function that you swap it out with this piecewise function, and then deal with the problem in its component parts. Right, so for any real valued r, we define the absolute value of that variable to be x if x is bigger than 0, or minus x if x is less than 0. So we may think of the absolute value of x as giving us a distance from 0 to that number. Right, so if I say, what is the absolute value of -2? You can think of this as, what is the distance from -2 to 0? And that would be this distance, right, 2. On the positive end, it's the same thing, right? So if I say, what is the distance from 5 to 0? That's 5. Here are some interesting properties that the absolute value function satisfies. That is to say that for any number, its absolute value is greater than or equal to 0. For any two numbers, if you take the product of them and then take the absolute value, this is actually equivalent to taking the absolute values individually and multiplying afterwards. And this one you'll get a lot of use of. So if you need to take the square root of something, you have to understand that that's going to change its domain, or its natural domain. So if you want to take the square root of x squared, that doesn't go to x. That goes to the absolute value of x. And because you're looking for all numbers who multiplied against themselves give you, say, 9. Right? So the square root of 9 isn't only 3. It's also minus 3, because minus 3 times minus 3 gives you 9. Right? So this is what this is saying. So the square root of 9, in this case, would be the absolute value of 3 squared, which is 3. Set notation. So here's a bunch of other operations that we can do on sets. Have you guys been shown this ever? No. Jeez. Well, suffice it to say that, and I appreciate your honesty, because if at least one person doesn't know something, I guarantee there's like 20% of the class. So please never be ashamed of asking me questions, because I guarantee you're not the only one who's misunderstanding, and I'll give you bonus points for being honest. So A+ for you, miss. You may leave. No. So if you want to take the intersections of two sets, so suppose you have a set A, a collection of real numbers, a set B, a collection of real numbers, the intersection of those two sets, you guys done Venn diagrams? So like this could be A, and this could be the set B, and this there is the intersection of A and B. It's the elements that belong to both sets. The union of two sets is just you take both sets and you make one big set comprised of both of those elements. I can say something like, is 0 in that set? And we use this special E. This is the E. This is element of. It is not that one, which we use for something different. That's sort of italicized E. And we can also say not an element of. So here's two example sets. So the first set is 1, 2, 3, and the second set is 4, 5, and 6. So first let me ask you a few questions. Is the set 1, 2, 3 a subset of the natural numbers? You say yes, you are correct. Is it also the case that A is a subset of the real numbers? And it also, yes, great, okay. So you can be a subset of many things, right? So this subset is A, a subcollection of itself. Okay, so what does it mean for something to be a subset of something else? It means that if A is a subcollection of B, everything that you find in A can also be found in B. So is it the case that A, every element of A is found within A? So it is the case that A is a subcollection of itself. It's the case that for any set, that set is a subcollection of itself, provided you're allowing them to be equal and not using strict equality. Okay, so here are three statements here. So what are the members that belong both to A and B? The intersection of A and B. Well, 1's in A, but it's not in B, so that's not in it. 2's in A, but not in B. 3's in A, but not in B. And all that same stuff from B is not in A. So what is the set with no members? Well, it's this. That's how you write a collection of nothing. Or you can just write empty braces and put nothing inside. Another way of writing it is like this. A 0 with a line through it. This is a special set called the Null Set. I'm not going to explicitly test you on this stuff. I just need to get you a little bit comfortable with some notation that we will be using once we start talking about other stuff. Here's the union of the two sets, right? That's just both sets, and you just have one big set. Had there been duplicates, I wouldn't have included the duplicates, right? Sets basically are unordered, unique elements. So you could never have a set 1, 1, 1. Right? You'd have the set 1. Okay, so let's answer these two questions. Is it the case that 1 is in A? Is it the case that 1 is not in A? Yes, no, it is the case that 1 is not in A. Right? So we'll usually write this because that's a much more direct statement. You should never really write something down like this. That's false. Like you should always write on paper stuff that's true. As soon as you write something down that's false, as a marker I can circle that and say this is wrong, therefore everything subsequent to this must also be wrong. Right? Because you can never determine something true from something that you've done incorrectly. These are a bunch of standard sets. I hope you've seen most of them. Have you seen these symbols for denoting these standard sets? So this bold-faced N denotes the natural numbers, which should include 0. So I don't know why I didn't include 0. Oh, it's because last year the book that we were using didn't include 0 in the natural numbers, and they made a hell of a lot of other things confusing. So our natural numbers are going to include 0. I'm going to have to change this. The integers is just the natural numbers plus the negative versions of those natural numbers. So 0, 1, -1, 2, -2, and so on. The rationals, as I mentioned, are a collection of fractions. So you generate this by saying Q is a collection of numbers A over B such that A and B are both integers and B can't be 0, right? Because you can't divide numbers by 0. And for the reals, since I can't give you a real strict definition, I'm just going to give you this hand-wavy definition, which is self-referential. The collection of real numbers R is X such that X is a real number. Right, because I can't give you anything better than that. Are there any Germans in this class? Great. So now I can tell you that the reason that the integers are denoted by Z is because Zahlen, which is a terrible pronunciation of that word, which is why I asked for Germans first, so they could do it. That's the German word for number, is Zachen, or whatever that is, right? So that's why we're using Z as the letter for the integers. It used to be I, but we got rid of that. Okay, so what is normally going to happen is that I'm going to lecture you guys for a while, and then I'm going to fill the remainder of the class with exercises, right? Because it is absolutely necessary to practice a bit. So today it's going to be for about an hour. Subsequent classes I'll probably do this much less than an hour because some of the material is going to get a lot more time-consuming to teach. So we got to do this quick, right? This is only slide 11 of 23. So when we do this exercise. I'm going to give you 5 minutes, and then we'll take it up. And you can chat, you can work. Like, this is not for grades. This is really just to try and figure out why you're stuck, where your weaknesses and strengths are. And this will be the most riveting part of the YouTube video. Anyone want to tell me what it means to solve something? Nope. Nope. But that's a good steps towards solving something. But what is being asked for in this question? All of you grabbed your pencil. So what are you doing? That is correct. Okay? To solve in this context means find all x's satisfying the condition. So why did I spend the whole class talking about sets? How do you think you should return your answer? Your answer is going to be a collection of values that satisfy a condition. How can we collect numbers into something? Using what? That is the correct answer, right? Sets. You collect your answer into a set. Your answer should be a set of x's such that those x's satisfy the equation. But this was a lesson. You jumped to the paper before reading the question enough, in my opinion, right? Because even the word solve should take some consideration. You should have an idea of what you're trying to do before you start, right? There's no rush here. And you got to be a little bit more thoughtful about these things. I'm trying to train you for writing the midterm, so remember, I'm coaching you. So I'll give you to 12:05. Yeah. I'll do a lap.
Well, there's no greater than x. It's like only one possible value. It's only one value.
Okay, so
It is. Very close to looking math. We will make it good. It's okay. It's okay to be frustrated because first step. And it will be your last step. We gotta first look at this. You gotta ask yourself why you're not stuck. How does it help? The answer is that you're very close. It's not the right way to say. If I say something like less, let's say. Big. Big. And which gives you tells you what big is. Actually, little works. That's good that we put little x. That's supposed to play with this. Yeah. We're almost. Oh wait, that's great. You can't. I'm sure. No, convince yourself you can't do it, then you won't be able to. When you brush tape, faster you approach, like, try to stay positive. Okay, how do we go? Who has all of them? Who has not all of them? Okay. Great. At least you guys are honest. Where are we stuck? All of you just rose your hand to tell me you weren't finished. And now none of you are telling me where you're stuck. So this is amazing. Yeah.
I was stuck on the
First question. Okay. Why?
So we were discussing what you actually mean by assess, and we sort of. So the first thing we did is we rearranged the equation to make to see which like x's cannot satisfy it. So we decided that x cannot equal 0 and it cannot equal -1.
That was a good first step. So remember, when I say solve these equations, what I'm asking for is a collection of numbers for which it will satisfy this. What do I mean by that? If I make x equal to 7, does it work? I put a 7 in here, I get a half. And I put a 7 over here and I get -3/7. Is a half equal to -3/7? No, so that is not in the solution set. So if I denote the solution set, so how should I say this? I'll just call it S equal the solutions. You shouldn't even have solved this yet. What can we read from this? What numbers do we have to remove immediately? Yeah, so we know that x cannot be 1, so -1, because otherwise we divide by 0. And it can't be 0, otherwise we divide by 0 over here. That's called an implicit restriction. Right? So if we solve this, if you have one of these as your solutions, you're wrong. Right? So remember, there's a lot of stuff that's hidden in these questions that you have to be mindful of. I draw a line. So you should always be writing top down. And if you want to continue, you strike a line and you continue in columns. Okay? Don't draw arrows. This isn't a sort of like a mat that you find in a restaurant, which I have to follow. Right? You want to make it very clear to the TAs how to give you partial marks. Okay, so we know that these aren't in the solution set. So given this equation, I do this a lot just so I can refer back to something. So I'm saying this equation, and I'm going to use this a lot. You know what this means? Implies. This is something that means inference. This means if this is true, then something else will be true. This does not mean equal. Equal literally means two things that are the same. Right? Don't write something like this. Right? 3 is not 7. You write something like this, the markers are going to go like this. But be careful. What you write in mathematics has very strict meaning. Right? If you don't understand the meaning, then you're writing in gibberish. You have to write down something that you yourself understand. Right? Don't just try to write something that looks mathy. It won't work. The TAs can identify stuff that's meaningless. Okay, so let's continue. Okay, so given this equation, asterisk or star, from that I can deduce that 4x is equal to minus 3x plus 1. Most of you should have been able to get here, yes? This further implies what? Well, this is minus 3x over here gives you 7x is equal to minus 3, which means x is equal to minus 3/7. Should be the solution. And that's an okay solution because we don't have to exclude it. Yes, sir.
We tried that and we plugged that back into the equation. It didn't satisfy.
Okay, so let's give that a try. So that's a good point. You can check your solution. You should check your solution, especially if it's a midterm or a final. So let's just perform that. Let's check. So you're saying you put minus 7s into there, and it didn't work. So 4 over 1 minus 3/7 is this equal to minus 3 over minus 3/7? So what is 1 minus 3/7? Huh? It's what? 1 minus 3/7 should be 4/7. And then if I have 4 over 4/7, that's going to leave me with a 7. Well, same thing here. So I say check your work, Nate. Oh no, here's the other thing. I'm going to make tons of mistakes. So if you find yourself at home saying, I could have sworn to God 3 plus 2 is 5. But Professor Verbeek wrote 7, so it must be 7. No, I'm going to make tons of mistakes. So please tell me. Don't assume that I'm doing things perfectly. In fact, assume the opposite of that. Assume I'm going to make tons of arithmetic mistakes. Okay, so let's move ahead. If you haven't finished these in class, go home and do them. And you, remember, if you can't solve them, why? Why can't you solve them? Does anyone have an idea for what should be done on 2? Everyone remember the quadratic equation? Is this a quadratic equation? Not yet, but this is 2x squared squared minus 15x squared minus 8. That's a quadratic equation. So remember that you can solve quartics like this by using quadratics. Try that at home. This one, 3 and 4, are inequalities. Right? So we have both equalities, that's x's for which two things are equal, or we can have inequalities, which are going to give you intervals on the real line. There'll be infinite many solutions to 4 and 3, I think. So give those a try at home. Those are the answers for you there, just so you can confirm that you got it right. I'll try to put, yes, sir. Yeah, but maybe you should write them down because I may be lazy. I'll post them, but we don't have a website yet or not. Would you? So I kind of hate Quirkus, so I'm going to try to put them on Piazza. Yeah. All right, let's keep going. Solve the following systems of equations. So what does this mean before you begin? Any ideas? So when I give you one equation, so this is really important. The notion that when I give you an equation, those equations correspond to collections of real numbers for which that equation is satisfied. That's an equation which basically says, I am a rule, and the only thing satisfying this rule is the number
minus 3/7 in that case. We could come up with other rules, right, that allow for an infinite amount of things to be true. So I can say, if I took that question and I added another rule, I said the first rule is what we have written, and the second rule is x has to be positive. How many solutions would I have in that case? How many of the solutions for question 1 did we find that were positive? How many solutions did we find? 1. Is that solution positive or negative? How many solutions did we find that are positive? 0. That means if I added another restriction to that equation, we would have found nothing satisfies it. So what I'm asking for here is I'm saying, look, I'm not giving you a single rule, I'm giving you 2 rules. How many of x's satisfy the 2 rules simultaneously? Right, so give this some thought when you go home. And there's the solutions for those ones. And be sure to read instructions where I'm saying express your answer using the interval notation, which is why I had to show you the interval notation, because otherwise you'd have no way of writing solutions to questions like these. And it's important that you understand how to use this notation for 2 reasons. I'm going to use it, which means you have to be able to understand what it means when I use notation, and you have to write with it in order to communicate to your graders in such a way that they're going to give you grades. Right, so calculus is really about learning how to write solutions in a rational manner, in such a way that they're like universally understood. Right, so that's the purpose of mathematics. It gives you a structured way of communicating your solutions. Because if you have the solution to some problem, but you can't communicate it, then your solution is pointless. Right? You need to be able to communicate things to other people. And calculus, or mathematics generally, is a framework for helping you do that. This is why this is the language of science. It is important. Solve the following and use interval notation whenever possible to express your solution. Why don't we do 2 right now? So find me the collection of numbers such that 3 times the absolute value of x minus 7 is greater than or equal to 11. And I'm just going to look ahead to see how much more we got. Okay. Well, you should solve them both of them individually. Right, so you'll get in both cases the set of numbers which satisfies the first equation and the set of numbers that satisfy the second equation. And then you want to intersect those 2 things. Right, so in fact, it would be correct for you to say it's the intersection of this and this. It would be better to actually write something a little bit that's more simplified. But so what did I say at the beginning of class regarding absolute values? So when you have an absolute value, you can break the function up into 2 pieces. Because remember, you know what the absolute value does on positive numbers and on negative numbers. So you should solve this number 2 in 2 steps. How does it solve assuming x is positive? And how does it solve assuming x is negative? I'll do a lap.
Please bring like paper and stuff to class because we'll be working.
Set one equation, get rid of that. Set one equation, 5, set one minus 5. The second one you want to do 11. Set it so it equals 11. And solve it. Whatever you get, so you should get 6. So when you get 6 on underneath me, it has to be more or less than minus 1. Depends on which way around. And then 3, I got the last one. But it's assuming positive. That's only part of it. What's that? X has to be less than 11 over 2. So we solve the other part. To make it minus 4. Minus 7. X is 3 over 2. The other. It has to be greater than.
Okay, so I'm not trying to be.
I got the right number. Don't worry about it.
Criticism. Intelligence. I'm asking you. Yes. Those numbers are which you plug in and by restriction. Put in zero. Zero is the number. Such that the set x equals Okay, I'm going to do this one on the board, and then we'll move on. I'll show you what I mean. I'm going to write it in such a way that I want you to write it. Right? What I'm writing on the board is not just for me, it's for you. So I'll give you a little bit of the conversation I have with those gentlemen over there. You need to write your work so that a marker can read it. Right? So you should come back, ideally you should be working in pairs. And then you hand off your work to your partner. And if your partner can't understand it, and you don't get to stand behind your partner and say, go from here to here, this is what I meant when I wrote this is what I meant. No. You have to get in the habit of writing down solutions that can stand on their own. And if you can get in this habit, I can give you tons of partial marks, even for things that you answer incorrectly. Because you're at least demonstrating that you have a capacity to communicate with me properly. Right? We'll worry about getting the correct solutions later, but at the time being, you need to sort of level up the way that you write down math. Even and especially when you're doing rough work at home. No more laziness, right? We have to write down in all ways. You should always strive to write down your solutions so that you can return to them a week later and understand them. In fact, you should be returning to your solutions from a week before and correcting them, or saying, whoa, why did I write this? Or why didn't I add something like this? So if you can't understand your own solutions, no way a grader can understand your solutions. So you should strive to try to write in a structured way like I do. Okay, so there's a lot of a habit to do this. Okay? Your high school teachers taught you to do this. Stop doing this. This is called like a red line. This is called a grocery list. We do not want to see this. This is not effective. Either you deduce like this: A is equal to B is equal to C is equal to D is equal to F. Right? It's implied that this is a giant chain of equalities. I don't know what the difference between this, I don't know what the association between these things are. Right? This says that A is equal to D. Does this say that A is equal to D? No, a lot of you are writing in such a way that you want us to go from like this. Well, that's not the case. If you want to do something like this, you have to say A is equal to B, which implies C is equal to D, which implies E is equal to F, which implies G is equal to H. Okay, any other criticisms about how I wrote this on the board? Yeah, criticize me. The same way I criticized you. How do humans read in English? Left to right. Okay, now when I was writing this on the board, I knew I was doing it like this, yeah? If you were to come in a week later and look at this, you would read like this, wouldn't you? If you were to give something like this to our TAs, they're going to read like humans, left to right. I'll show you a magical thing that you can do to unconfuse them. All it takes, a single line, and you will demystify your work. Right? These are the little pieces of helpful strategies that I hope you can use to get your grade up. Right? But again, a couple lines, and now this is readable, which is important. Okay, so let me just solve this problem. So what do we got here? Oh, it was 2 you wanted to do, because I told you to. 3, absolute value of x minus 7 is greater than or equal to 11. So I'll show you how I'll do it. I usually break these up into 2 cases. Right? So I look at this, and I say if x is bigger than 0, then, we'll make this equal. If x is bigger than or equal to 0, then this equation implies that 3 times x minus 7 is greater than 11. Yes? That means furthermore that x is bigger than or equal to 11 plus 7 is 18 divided by 3 is 6. Okay, so I found some solutions, right? So it has to be the case that x is bigger than or equal to 6. Is that it? Okay, prove to me that this is not all of them. How about minus 1? Well, if I put minus 1 into there, you get 3 minus 7 is minus 4. That's not bigger than 11. It is true that it has to be less than 0, but that's not small enough. Less than 1. Okay,
That's not 6.
almost.
Negative.
-6. Yeah, okay. And I'll show you how to deduce that with algebra. Right? What's the other case? I did this. I made an assumption that x is bigger than or equal to 0. What's the other case? Right. X is less than 0. What does that mean? That means that this equation can be rewritten. What is the absolute value of minus x? Or what is x when x is less than 0? What is, well, I'll just write it. Okay? This says when, believe me. I know, so in this case, I have x is bigger than or equal to 0. So when x is bigger than or equal to 0, I can replace the absolute value of x with x. That's what I did, right? Under this assumption, I can replace this absolute value of x with this x. Under this assumption, I replace the absolute value of x with minus x. Then I just write minus, well, I'll write it like this. 3 minus x minus 7 is greater than or equal to 11, which means 7 goes over there, it becomes 18. I'll do it in 2 steps. You get minus 3x is bigger than or equal to 18, which means you get x is less than or equal to minus 6, which is what you discovered as a solution. So how do I tie this all together now? What is the collection of numbers for which satisfies that equation? Yes?
So we're gonna put like x, like that thing, the thing, and then it's gonna be like x such that
You're building a set for me, right?
yeah.
So what are the 2 sets that you want?
It's gonna be like, it has to be between 6 and -6. The x is gonna be in the middle, and then
Okay, so you want x has to be in minus infinity to 6, or minus 6 inclusive, and 6 inclusive to infinity. That's one way of writing it. There are other ways of writing it. You wrote probably this. X such that x is greater than or equal to 6. That would be okay.
yeah, but I put both.
Sure, another way of writing it, you could do it like this. So the collection of solutions, and notice that this is inclusion. I didn't write equal, right? What happens if I say equal? Is this true? Why? Yeah, this is saying I could take this collection of numbers and put it into here and that will work. No, that's not the case. Right? It has to be a number. These little things matter. I'm not going to remove marks from you for that. I wish I could. Right? But I don't want to penalize you too hard because I want you guys to do well. But just know that in my heart of hearts, I want to penalize you for what I consider mathematical, grammatical, and spelling errors. Right? But I won't, right? Because I want to get you guys out the door. Okay, so the other way to write this is x is a collection. X has to be from the collection x such that x is greater than or equal to 6. Or x is less than or equal to minus 6. Be careful. It's or, not and. Right? There is no number which is bigger than 6 and less than -6. So it's an or. All right, so I'm just trying to convince you that we have to be very careful with how we write stuff. 20 more minutes left. Okay. Those are the solutions if you want to take them, the rest of them at home. I recommend that you do the rest of them at home, especially this one. Remember, your performance and outcome in this course will be very correlated with the at-home work that you decide to do. Okay, and the last, yes, sir. I hate these questions. You're going to get marked correctly if what you have written is mathematically correct, right? You're asking me, we have these equivalent, I understand why you're asking this question, right? I want you to get a maximum amount of
marks on your test. But that's the wrong type of strategy, right? It's like you just asked, well, we have these things that you just shown were equivalent. Which one is preferred? It's like, well, they're equivalent. I don't care. As long as you like write something that's correct, then I'll give you the marks for it. So I'm never going to say, oh, well, this is correct, but written in set format. I wanted it in, well, that being said, if I write an instruction that says, give me the solution using interval notation, which, did you guys read this part? Some of you didn't, because you didn't use the interval notation. If this was a midterm, and I say use the interval notation, and you give me that, you are wrong. And it's a pretty shitty way to lose some marks when you write the correct thing in the wrong way. So that's how I'm going to answer that. It doesn't matter normally, but it does matter if it's an instruction that we have given you. Okay. Yes, miss. What is this set builder notation? Yeah. Because it's a set and we've built it. Yeah. Okay. So did you guys read that chapter on problem solving that you were assigned? Really? Neat. Did you guys read it? Who's lying? A+. A+ for honesty. Okay, please go read it. That's something that was recommended by the other instructor. I've never used that type of strategy, but it's good to like try a bunch of different things, right? Because I may be very biased in how I'm teaching you using a very particular type of learning style. This chapter will teach you about the different types of learning styles and approaches that you can take. Because what I observed last year when I taught this course was that most of my students were very good, competent at mechanics. They could add fractions together, they could take derivatives, most of them could even perform integrals. But what they couldn't do, or what they needed help to gain competency in, was problem solving. Right? It's the problem solving is the thing that you guys are going to need practice with, because the mechanics, the practice for that comes as a consequence of practicing problem solving. Right? So I'm really going to try to give you strategies for how you have to look at a problem, especially when you get stuck. Being stuck is a real terrible feeling because it feels like you're wasting your time. But like, no, just because you're not writing something doesn't mean that you're wasting your time. Thinking counts as work, right? And thinking doesn't necessarily mean you have to be dumping something onto a page, right? So being stuck is healthy. Try not to get frustrated. Remember, write down why you are stuck. That may actually get you unstuck. Okay, so we have this problem-solving framework. I forget the author, but there's a link in Quarkus. You should read it. It's maybe 5 or 6 pages. It walks through several problems. They're fairly interesting, some of these problems, like all palindromes are divisible by 11 or something like that, which I thought was cool. Okay, so here's a question that all of you should be able to answer, because this is pre-calculus stuff from high school. I expect most of you won't be able to do this, which is why we're starting with it, because I want you to start practicing how to unstick yourself. So here's the question, but I'm going to walk through it with you. So let's read it together. Okay? Find a quadratic polynomial, p of x, such that p of x is strictly greater than 0 when x is less than 1 and x is greater than 3. Px is exactly 0 if x is equal to 1 or x is equal to 3. And px is less than 0 when x is in the interval 1 to 3, exclusive on both ends. Okay? Now I'm telling you, so here's another problem for my students last year. A lot of them would come to me saying, I have no idea what to do here. And I would say, let me just rephrase the problem in English. And they said, well, I can do that problem. Okay? So there shouldn't be so one of the things that you have to become good at is taking mathematical notation in language and converting it into English. And that should always be maybe one of your first steps. Asking yourself, what are they asking me to do here? And you should spend a lot of time in like the pre-phase of answering a question. You should really sit down and read the question and ruminate on it a bit. Right? The solution won't come immediately. And there's some struggle is necessary. So let's go through this and let's be honest. What does this question ask? Or why are we stuck? Okay, so we're going to walk through this. You're going to reflect, personally or in partners. So we are going to understand the statement of the question first. Okay? For each of these concepts, write down what it means on your paper or think about it, or write down stuck. Okay, because we have to go through the components of this question. What are the things that we definitely need to know to do this question? Like what words are sticking out? Yes, miss? Quadratic. That's one thing that we need to understand. Well, what else? Polynomial is another thing that we have to understand. What else? Well, what does this condition say in English? What does it mean for px, a quadratic polynomial, to be greater than 0 on that domain? Yes, sir. What does that mean? What's positive? I'll accept that. Okay, so the other thing that is very, very important is this. We can write down statements like this on the board algebraically, and most students prefer this algebraic method of work. Right? This is because you get to just work out with equations and do things mechanically. There are rules that you follow, and it's necessary and good that you're good at that. What is missing is the fact that each of these equations correspond to graphs. Every statement is both a statement about a picture and about an algebraic statement like this. And in fact, these algebraic statements are the only way we as humans have to describe shapes that are like unvisualizable by us. Like watch. What's a circle? I don't believe none of you know this, so I'm just going to wait. Yeah. I'm not trying to trick you. Yeah. Technically true, so it's the best type of true. But if you had to so an alien species comes down and you have to explain to them what a circle is. How would you do it? Imagine a piece of paper. Put a dot on that piece of paper. Now, draw all the dots that are equally, that are 1 unit away from that dot. That's a circle. Go into 3 dimensions. Choose a dot in space. Pick all the dots that are equally far away from that dot. That's a sphere. That's a circle in 3 dimensions. Go to 4 dimensions. Pick a point in 4 dimensions. Choose all the points in 4 dimensions that are equally away from that dot. That's a circle or a sphere in 4 dimensions. There you go. I just described to you the hypersphere, right? But this is why mathematics exists. I can very easily describe objects in the 4th dimension that you can't visualize, which is wrong, because the visualization comes by way of these equations, right? So equations are themselves visualizations of mathematics. It's just a very particular one. So going back to what that gentleman set up there, this first statement is something about, so a quadratic polynomial is a parabola, yeah? And I can put a parabola I can draw one. And for what it means when px is greater than 0, it means that the parabola should be above the x-axis on that domain. Right? So you need to sort of take these algebraic statements and convert them to statements about the geometry of the problem. Because sometimes it's very easy to solve the problem geometrically and impossible to solve it algebraically. And other times it's very easy to solve it algebraically, but impossible to get it geometrically. Like, I can't draw you a 4-dimensional sphere. Well, I can. It just has to be animated. It's pretty cool. You can look it up. Hypersphere, hypercube. Okay, so in the last 10 minutes, let's go through quickly. So we're going to understand the statement of the question. For each of these concepts, write down what it means or write stuck. What does it mean to be a quadratic polynomial? Stuck can be your answer. You just have to go home and unstick yourself. What does it mean to be a parabola? What does this statement mean? Px is 0 if x equals 1 or x equals 3. Can someone give me a geometric description of what it means for a parabola to be 0 at x equals 1 or x equals 3? Yes, miss? On the parabola? Parabolas have endpoints? You can get it. I know, so this is mostly the problem. I know you know what the answer is. The problem is you can't communicate it. right? So we have to just, I need to be able to extract the correct answers from your brain. You're trying to come up with the word intersect or cross, right? This is a parabola, yeah? Each point here is a point x, px. We'll talk about this next lecture on Wednesday when I talk about graphs. But these each are the values px. So all values here, right? It is the case for this parabola that px is greater than 0 for every x. These parabolas can do this. And they got these things. Right? These are called roots or solutions. That's because here you got a value x0, which are important for a variety of reasons. But again, right, we need to be able to take these statements of mathematics and convert them to statements of geometry. And once you do that, this question will be easy. What does it mean that you have to give me a polynomial of your choosing in the end of this? Because that's what the question's asking. Give me a polynomial satisfying the following conditions. From the information we have already, we want to draw a picture. This will give us a geometric understanding of the problem. For each of these tasks, explain what to do or write stuck. What does it mean for px to be 0 if x is 1 or x is 3? What does that look like in a picture? So just label this guy. Will the parabola open upwards or downwards? How do you know? Where will the vertex of the parabola be? What's the vertex of the parabola? Yes, sir. Yes, that's the vertex. It's the only thing that the parabola has one of. You can remember it like that. Right? The vertex. I'm just full of these handy tricks. Is there only one possible value for the vertex, or there are many possible values? How many parabolas have vertex at the origin? 1? 2? Imagine a parabola at the origin, going through the origin. That's one of them, right? Flip it. That's another one. Compress it. That's another one. Decompress it. That's another one. There are clearly an infinite number of parabolas that go through the origin. There are 3 forms of the parabola: standard, vertex, and root. They're all different, and they're all useful for different things. So reflect on them. Which one here would be most useful to you? You know what? That should be it for today. Oh, last question. Yes, miss. All right. That'll be it for today. I'm going to hang around for 10 minutes if you want to talk to me about issues that you have personally. Otherwise, I'll see you Wednesday. Come to work. I'll put this up on at least Piazza, if not both Piazza and Quarkus. Hello.
Okay.